Welcome to Lesson 2. We're going to be taking our first deep dive into sentiment analysis using Chapter 2 from our Text Mining with R book. And this is going to be our primary reference for this lesson. We will not be doing any swirl lessons for Lesson 2. However, I will state that for our next lesson, it will be a supplement to this lesson because this one I want to keep it from getting a little bit too lengthy. We will be doing some revisiting the dplyr package using one of our swirl courses, and also we'll take a look at one of the data camp sentiment analysis with R by the author of this text, Julia Silge. So just to kind of prime you and prep you for Lesson 3, we'll be doing some swirl courses and some data camp courses for supplement to this lesson. But I wanted to take Lesson 2 just dedicated to Chapter 2 for the Text Mining with R book. And also Chapter 9 will be examining a case study of using the Usenet Text bulletin boards from the early 90s and reading through a case study of doing some analysis with these. Specifically, we'll be looking at Section 3 of Chapter 9. You will not be required to do any of the coding that's here in Chapter 9. That will be entirely optional. However, if you would like to give it a try, it is a little bit challenging. Obviously, the code is probably going to work for you, but understanding everything that's going on in the code might be a little bit of a challenge. But she does do a nice description of doing some sentiment analyses with these news groups. If you work with things like discussion forums or MOOC data or things like that, this is actually a good use case or a good example of doing some sentiment analyses with these sorts of online discussion groups. So anyways, let's go back to Chapter 2. The TinyText package that the author created, and that is kind of the centerpiece of this book, includes 3 different lexicons for sentiment analysis. Specifically, the AFFIN lexicon, the Bing, and the NRC. And she does a nice job of just briefly describing how these came about in their approaches for validating these, and especially the context that they should be used in. And then the distinctions between each of these as well. And if you'd like to learn more about each of these, there are links here, and you can find out a little bit more about how these were developed and how these were, how they attempted to validate these dictionaries. But anyways, let's go in and just get set up for working through some of these examples in Chapter 2. So obviously we are going to need to load the tidyverse package, so we have access to dplyr, which we'll be using. We'll have access to ggplot, which we explored in Lesson 1 and we'll be using again. And then also another package we'll be using in this lesson is the tidyr package for doing some additional data manipulation. And also the stringer package too. So let's go ahead and load that so we can just load everything at once. The TinyText package obviously conforms to the tidy approach to working with data, but is not part of the tidyverse set of packages. So let's go ahead and load that separately. And then again, just to verify, we can go in here and make sure we have it loaded. And there we go, we can see it's loaded. Took a little while because my computer's running pretty slow recently. It's starting to show its age, just like its owner. Anyways, so let's go back to our sentiments data set and let's take a look at this data frame that's included in the TinyText package. So if I look at the package right there, I can see that within this package, well, first of all, we see a number of functions that are included in this package. Get sentiments is something we'll be using pretty extensively, but it also includes a data frame or data set of these 3 lexicons. So we can click on that. It tells us a little bit more about that, but let's actually just load it and take a look at it. So sentiments, and there it is right there. It includes actually 4 lexicons, okay. And let's get that loaded. So really quickly, it's just going to give us the first 10 rows of what that looks like. If we wanted to actually view it, let's go ahead and take a look. Oops, view sentiments. Oops. Spelling would help. And there we go. So as you can see, there's 27,000 rows in this, pretty extensive. But you can see a lot of these are actually repeated more than once, these words within these lexicons. So for example, abandon in the NRC Lexicon is associated with anger, associated with fear, and then it's associated with a negative sentiment. Also sadness as well. So you can see right there, let's actually do some filtering and we can take a look at the AFFIN lexicon as well. So you can see that one does not have a categorical label to it. Let me go back here really quick. The NRC has a number of different labels or categories associated with each word in this lexicon. However, the AFFIN lexicon just assigns a kind of degree of polarity of negative and positive to each of these words. The more more negative the score, the more negative association of the word. So for example, a word like abhorrent is scored a -3, and a word like, let's just, there we go, and there we go. So we can see that some of those words have very negative connotations. And then very positive words like breathtaking, hurrah, outstanding, etc., etc. So those are the 3 sentiments, well, 2 of them that we just took a look at, the NRC and the AFFIN lexicon. But let's take a look at each of these individually. So we're going to use the getSentiments function that is included in the TinyText package, so we can explicitly or specifically select one of these lexicons from the sentiment library. And what this function does is actually, we noticed when we pulled up the sentiments data set that includes columns, and some of which aren't applicable to certain lexicons. So for example, in the AFFIN lexicon, it does not include categorical or word descriptions of each of these words. It only assigns a numerical value, so that is a column that's not relevant to the AFFIN lexicon. So what getSentiments does is when we select the lexicon that we want to use, it will go ahead and just filter out the columns that are not relevant for the analysis, so we don't have just a row of empty columns. Oops, had it right the first time. There we go. And if we wanted to, we could also take a look at this one too. One of the things I like about RStudio is the ability to just explore data sets in the viewer. So let's go ahead and take a look at that one. And there we go. So as you can see, obviously for this one, words are not repeated. Words are not repeated more than once because they're only assigned a single score as opposed to multiple categories like joy, positive, negative, anger, etc., etc. So this includes 2,476 words. Let's also do the same for these other lexicons that we'll be using as well. So we can see the Bing lexicon. That's the one we haven't talked about at this point, and that just includes 2 labels, just positive or negative. And we can also see that that includes a little bit larger lexicon or dictionary than the AFFIN lexicon. And then finally, let's go ahead and take a look at our last one as well. So NRC, and let's go ahead and take a look. There we go. Because each word is assigned, in some cases, multiple categories, you can see that there's repetition for some of those. So there's not 13,000 words, or almost 14,000 words in this, because some of them are repeated. So in a nutshell, those are the 3 lexicons that we're going to be working with. There's a good description in the book about the context in which these lexicons were used, and that will give you an indicator of which one might be most appropriate for down the road when we're working on our data project, which one might be most appropriate to use for the data set that you want to analyze. One thing to keep in mind that Julia mentions in the book is that because these lexicons were developed fairly recently and they were used for the most part on contemporary text. So for example, the AFFIN I think was used on Twitter post. So because of that, because it's more contemporary, a lot of the things, some of the text that we worked with from the earlier lessons in Unit 1, like Jane Austen, it's not going to be in some cases, an accurate reflection of the use of those words in those contexts. And we'll see a good example of that later in this chapter. So what we need to do, if you recall from Unit 1, when we were pre-processing the text and getting it ready for analysis, we used something called an anti-join. And that basically took a, let's call it a lexicon of stop words, and it looked for matches of those stop words from our tidytext. And then where there were matches, it basically just filtered out all of those stop words from our data set. We're going to be doing something a little bit differently. We're going to be using a function called a join, which is similar to the anti-join, except instead of removing things, with this inner join, we're going to look for matches in both of the data sets. And where we see the matches to the words that are in the sentiment library, lexicon, and words that are in our data set, it's going to look for those matches, and it's going to keep the data from both of those data sets. So to help make that a little bit more concrete, because that sounded a little vague there, let's go back to this resource that I shared from Unit 1 that explained kind of what a join is and what anti-joins do. And let's take a look at the example from inner join. So in this case, we have two data sets, two data frames here. Over here on the left is our data frame of interest. This is what we're starting with, and you can see that we have a column for publisher and that the year that that publisher was founded. And then we have another data frame over here. So think of these as two separate data sets. And in this one, we also have a column for publisher, so we can see who the publisher was. But we also have some additional data. And the goal of the inner join is to find matches between these two data sets and keep the data that belongs in both data sets where there are matches. So in this case, we would be matching on our publishers column over here. And we can see that this one has DC, Marvel, and Image, and this one has DC, Marvel, and Dark Horse. Because there's only a match between DC and Marvel, between these two data sets, it's going to keep this information over here, the year founded, and then it's going to add this information for the DC and Marvel comics over here. So now we can see that we've created a new data set that contains all the columns from the two previous data sets, but only for those cases where we had publishers in both data sets. So that's kind of how an inner join works. So let's do some practice now with the inner join. And I've gone ahead and those Jane Austen books, this code This code should look pretty familiar. This is from Unit 1 when we were working with the Jane Austen books for doing some word frequency counts, some word counts. So I've already gone ahead and added that to my R script here. I have not loaded, I have loaded dplyr and stringer because they're part of the tidyverse packages, but I have not loaded the Jane Austen R package. So I'm going to go ahead and do that. And then let's go ahead and get our tidybooks data set. All right, there we go. So, and let's take a look at that really quickly. Again, this should look very familiar. So these are our books, and we've already gone ahead and cleaned that up just like we had last time, where we've tokenized the text. In this case, we have not removed any stop words yet, but that's okay because stop words are going to just be automatically, stop words are going to automatically be excluded when we do our our inner join for our sentiment lexicon. So in this first round of sentiment analysis, the author is going to be using the NRC Lexicon to help her identify the most common words associated with joy from the Emma Jane Austen book. So in order to do that, first thing we need to do is go ahead and get our NRC lexicon that we're going to be using. And if you remember correctly, if you remember from before, get sentiments is going to take that sentiments data frame that we worked with and that we took a look at. See if I can pull it up. There it is. And it is going to extract there we go. It's going to extract the NRC lexicon, so that's going to include the words and the sentiment associated with those words. So let's go ahead and do that. And also, since we are only interested in those words that are associated with joy, let's see if we can find one here. Oh, there's one right there. So absolution, abundance. We're going to be using our filter command from our dplyr package that you should remember from Unit 1 to just find those words associated with joy. So let's go ahead and run this. There we go. Before I do any filtering, let's go ahead and just take a look at what would happen if I just included all the words in the lexicon. So we can see up here now I have a new data frame, and I'm going to go ahead and open that up. So you can see when I do the get sentiments, since we've already specified what lexicon we're using, it's going to exclude that category for indicating what lexicon it comes from. So now we have the word and we have the sentiment. All right, and we're only interested in sentiment, the words associated with joy. So let's go ahead and just run this whole code. And now let's take another look at this data. And there we go. We can see the change right there. All right, so what we're going to do next is we're going to take that tidybooks data set that we created just a second ago. If you remember, it is right there, and that's all tidied up, ready for analysis. Again, we have not removed any stop words because since those stop words are not going to be included in the lexicon. So let's go ahead and take that tidybooks that we cleaned up, and we're going to filter out. I'm going to use our filter from dplyr, and we're going to tell it to look for the book column, and wherever it sees the word Emma, it's going to keep those and it's going to get rid of the rest of them. And then we're going to pass that along. So this is going to result in a subsetted data frame or a subsetted data set from our other books, and we're going to pass that on. And what we're going to do is we're going to join on the NRC joy data frame. And actually, you know what? Let's do this. Here I want to kind of illustrate what this looks like before we start doing some counts on those words. So I'm going to call this tidy Emma, and I'm going to assign it to a new variable or new object, and let's do this row by row. So now let's take a look at our tidy Emma. You can see we removed quite a bit of words there, quite a few words, roughly 600,000 words. All right, so let's take a look at that. There we go. So we can see now we only have our words from the book Emma, and then we still retained our chapter and line number. And now finally we are going to take that NRC joy data frame right here. And you can see we have word and sentiment, and then over with our tidy Emma data set, we have word, chapter, line, number. And here's what's happening. So we're taking our joy lexicon, and we're telling it to look for matches on the column word. Since we're not specifying what column for it to look for, it's just going to automatically look for a column that is present in both of the data frames. And where it finds a word that matches, it is going to append onto those words this new column called joy. And where it doesn't find any words, so for example, chapter is probably not included in this lexicon, it's just going to exclude those columns. So we're going to see a dramatically reduced data frame after we've gone ahead and done this inner join. So let's go ahead and do that. So now let's take a look at our tidy Emma. You can see it's shrunk down to 4,000 words. There we go. And let's sort these. All right, we can see I said 4,000 words, but obviously it's not that many words because many of them are repeated more than once in the book. For example, abundance occurs in the Emma book 5 times. All right, so now let's go ahead and do a count of those words. And this should feel pretty familiar from Unit 1. And now let's go ahead and take a look at our TidyBooks data frame. Oh, I'm sorry, we haven't stored this. Let's go ahead and actually store this as an object. All right, I forgot my little piping operator. Oops. And there we go. So now we're going to see that this is going to be reduce the number of observations because the words will not be counted twice. Instead, there will be a new column that includes the number of times those words occur. So there we go. So we only have 303 words that matched up with the sentiment lexicon for the word, for the joy sentiment. Let's take a look at those. And just by, let's see, it looks like by, oh, no, it hasn't. There we go. Let's just go ahead and sort those. So there we can see right away that the words that match up in the Emma book and most that are associated with this word joy occur here. So we can see good is repeated, used quite a bit in the book, not surprisingly, because it's a pretty generic word. So in our next example, Julia is going to walk us through sort of an examination of how sentiment changes throughout each novel. In order to do this, what she's going to have us do is she's going to introduce a new operator that we haven't used. This is a little bit more sophisticated for this course, but she does a nice job of explaining what exactly this operator does and what it's used for. And in this case, she's going to be grouping chunks of text from the book into 80-line chunks of text. And then she's effectively assigning an index number associated with those chunks of 80 text. So first chunks of first 80 lines of text, next 80 lines of text, and so on and so forth. So that way she can sort of create a timeline of the book. So let's go ahead and run this code over here. And let's also do this line by line, just so we can see what's happening. If you recall our tidy books from before, this includes all the books, all the words, all the lines from the book have been tokenized, and we're going to do an inner join. This time, however, we are going to be using the Bing Sentiments lexicon. And if you recall the Bing Sentiment lexicon, let's go take a look at it over here. Sentiments, and let's do some filtering. And let's just say the only ones that match for Bing, and there we go. It only assigns just positive or negative associated with the word. There's no sort of ranking or score assigned to it, and there's no additional categories. So let's go ahead and go back. There we go. And let's run this line by line so we can see what's happening. So now we have a new data set here. We've told it to go ahead and tack on those negative, positive labels for the words in that Bing lexicon. that match the words in the TidyBooks book. And obviously, not every word from this TidyBooks data frame is going to have a match in the Bing. So if there's no match, then those are going to be discarded because we only want to keep the data that includes a match from both data sets. So let's go ahead and take a look at that. And there we go. And let's just, there we go. As we can see, wow, abominable was used quite a bit throughout her books, including 1, 2, 3, 4, 5, at least 5 different books. That's really interesting. So what we're going to do next is we are going to, so in that book, for each of those 80 lines of text, it's going to be assigned a number. So the first 80 lines of text, I think, is actually going to be assigned 0. The next 80 lines of text is going to have a index variable for 1, and then 2, etc., etc. So we're saying for each book and each chunk of 80 lines of text, go ahead and get the sentiments for those. So let's run that. Again, let's do this line by line so we can actually see what's happening here. And let's go ahead and take a look at this Jane Austen sentiment now. There we go. All right, so in the first 80 lines of text, we can see that we had 16 negative words and 32 positive words. All right, and then in the next 80 lines, we had 19 negative words and 53 positive words. So in each of these cases, positive outweighed the negative, and it looks to be a ongoing trend, at least for like the beginning of the book. All right, so let's go back now, and we're going to be introduced to a new function that we haven't used before. And effectively, if you're familiar with SPSS or Stata, or have worked with data in long format and need to convert it into wide format, that's effectively what this function does. So just to kind of explain a little bit better, right now the sentiment, it is, excuse me, we have frequency or number of negative words for sentiment for this book, and also number of positive. And we're basically just going to say we would like a separate column for the number of negative words, and then a separate column for the number of positive words in each of those 80 lines of text. And that would actually allow us to get either a count of the difference, so we can get a sense of whether it's more positive or less positive, or even like do a ratio as well. So let's go ahead and do that and go ahead and take a look. All right, one more time. There we go. So we can see that before we had just a sentiment column with both negative and positive, and now we've pulled those out separately. And the reason that we wanted to do that is because we wanted to get a sense of, was it more positive or less positive for each of those 80 lines of text. So as you can see, as I had mentioned before, the first 80 lines of text had 16 negative and 32 positive. And now what we can do is with this mutate function, again from Unit 1, this should feel kind of familiar. We're going to create, well, actually we are going to create a new column called sentiment, because if you recall, we effectively deleted the sentiment column when we did the spread. So we're going to bring that sentiment column back. So we're going to create a new column called sentiment. And this column is basically going to be the difference between the number of positive words and the number of negative words. So let's run that now. So now we're running the whole chunk of code. It took us a little while, but I think it really kind of helped us get a sense of what's going on in each of these lines of code. So let's run that. And there we go. Now we have 5 variables, and we should have a new one now that's called sentiment. That is the difference between the number of positive words and the number of negative words. And there we go. So positive minus negative is 16. And then we can actually just quickly sort. We can see sections of the text, so sections of the book that were especially negative. So something must have been going on within those 80 lines of text in that particular book. And there's no reason we couldn't have simply have done, let's do an index for, here, I'm going to copy this, for just 40 lines of text, or even just like 5 lines of text. We just wanted some kind of marker, because if we tried to do the number, sorry about that, if we tried to count the number of positive and negative words for the entire chapter, as opposed to just 80 lines of text, I think Julie had mentioned this in the book, that effectively it's probably going to wash out across the whole chapter, because there's going to be a lot of positive and negative. And what we'd like to do is kind of get a sense of like where in this book there's more positive elements, negative elements, and how this changes over time. So let's go ahead and actually, sorry, getting a little distracted here, but let's take a look at 40 lines of text. And there we go. We still have some fairly positive chunks of text. It looks like in this one, especially later in the book then. But anyway, so that gives you a sense of how we can go about breaking a book into chunks so we can look at positive and negative like across the span of the book. When we get to a later lesson in this unit looking at tweets, we can use dates, for example, to see how sentiment changes over time. So let's actually just go back now. I just want to make sure we have this for moving forward. And oops, let me run that. And now it should match up with hers. All right, so now we get to the fun stuff. I'm going to go ahead and copy this over, and then I'll explain what's going on. But at this point, after lesson 1, it should feel kind of familiar. So this shouldn't look too unusual. All right, we've already loaded ggplot when we loaded tidyverse, so we don't need to load that again. And if you remember ggplot, the first thing that we need to specify 2 things. First off, we need to specify what data that we're going to be using. So in our case, we're going to be using the Jane Austen sentiment data, and we've already taken a look at that. And then what we want to do is effectively we're going to specify what's going along the x-axis. So in this case, it's our index, and it's a count of each 80 lines of text in the book. So that's going to be going across, basically across time in the book. And then we want to use the sentiment to effectively just provide our y-axis there. So actually you can see it right there. We're specifying what we want to be on the x-axis and what we want to be on the y. Because those are the first 2 arguments in this function, we don't necessarily have to specify it like we did in our previous lesson. And then this fill is just saying fill in the color based on the book. If you remember from the previous lesson, because we are specifying explicitly from this data set, we are going to include it in this argument. So again, that provides us our data that we're using, what goes on the x and y axis, how we want to color it. We have not specified what we actually want this to be yet. We want this to be a column chart. In this case, show legend is false. That's fine, we can keep that there. And then if you recall from lesson 1, facet wrap, I had mentioned that the author of the TidyText with R likes to use this a lot, so it's worth kind of digging into. But effectively, this shows us, this allows us to create multiple graphs based on a particular variable that we want to use. In this case, what we're going to be doing is creating multiple graphs for each book within this data set. And then you should recall this should feel pretty familiar. This is just saying in this kind of grid of charts that we're going to display, we only want to have 2 columns. And then we have this final argument, scales. Let's go ahead and take a look at scales because I need to jog my memory. All right, I'm going to have to dig that up and see exactly what that does. Let's go ahead and run that though. And there we go. So that's going to look very familiar, exactly like what we see in the book. Let's zoom this out and take a closer look. And as we can see, we get kind of a rough gauge of the negative and positive words used in each book over time. We can also see that some books are kind of predominantly positive, for example, Persuasion and Emma, whereas some books like Mansfield Park seem to take some very dark turns at some point. My wife is very familiar with all these books. I don't think I have read any of them, so I have no idea how to speculate what might be going on in each of those chapters. But that gives you a sense of how we can use sentiment analysis to look at changes in sentiment over time. In section 3 of chapter 2, the authors, David and Julia, give kind of a good explanation or a good demonstration of how there exists some variability in the application of these different sentiment lexicons to describe changes in sentiment within each of these books. I'm not going to run through all of this code for you, and if you'd like to, you can skip it as well. Basically, it's just an illustration of how there is some, she describes it really good here. So they do give results that are different in the absolute sense, but they also kind of give a sense of how within each of those books, within the Pride and Prejudice book, that there's similar trajectories throughout the book. So this is a good illustration of how each of these lexicon is going to bring its own unique or its own distinct interpretation, let's say, of the words, the sentiment of these words in the books. In section 4 of chapter 2, I think the main takeaway for this one is to just get a sense of how these lexicons, when applied in not necessarily the context in which they were actually developed, can bring about some obviously misclassified labels for sentiment, and that applies to pretty much any dictionary-based approach to doing text analysis. So these dictionaries are typically applied within or developed within a specific context, and when they're used like dramatically outside of that context, they're going to produce some kind of inappropriate results or inappropriate labels, basically. Let's run through this really quick, though, because this is just a good refresher. And I copy this code over really quick. So let's go ahead and run this code. Again, this is going to look really familiar. Doing word counts, Bing, and we're just sorting them, which we've kind of already done before, but let's go ahead and do that. And let's go ahead and take a look at it. We can look at it in the console down here if we wanted to. I'd actually prefer to look at it in the view pane, and then we can see a good example of misclassification. So as the authors point out, miss here is coded as negative. And given this context, the authors point out that obviously miss has been coded negative, but since it's used as a title for young unmarried women in Jane Austen's works, it's not really appropriate to call this a negative term. So this just provides a really good example of how sentiment lexicons, when they're applied to the wrong context, can produce some inappropriate results. I'm going to encourage you to go through this code and just get a sense of it and play with it, just because at this point you have some familiarity with ggplot now. So some of this should make a little bit more sense to you. And just for the sake of time, I'm going to move on to the remainder of this chapter. 2.5, obviously, we worked on in Unit 1, so word clouds are going to be pretty familiar. Go ahead and give yourself a refresher on this chapter as well. And if you'd like to play with the comparison cloud, there is a new function that we haven't learned yet called acast, and you can go ahead and work with that as well. Remember, you can always use the help menu to learn more about those functions. There we go. And there it is. And if you scroll at the bottom, you can see examples of it being used. She also does, or the authors do a pretty good job of explaining what's going on with this. So that's going to wrap up Lesson 2. Go ahead and read through this entire chapter carefully, work through some of the examples, go ahead and play around with the code a little bit to get a sense of what's going on. In Chapter 6, that's a good example of when they look at chunks of text that are a little bit bigger. So for example, at the chapter level, when I had mentioned using ratios, the percentage of positive to negative words, or negative words for the whole book, that's a good example there as well. And then finally, in Chapter 9, go ahead and take a look at the case study for doing some sentiment analysis for discussion, online discussion groups. And that's a good example of a good instance of how sentiment analysis can be applied to contexts like that. So that's going to wrap up Lesson 2. Again, there are no swirl lessons for this particular lesson because this is a pretty extensive chapter. We're going to do a supplement in the next lesson that is going to just introduce us. It's just going to provide us quite a bit of additional practice with both dplyr and with doing sentiment analysis using some of the new functions that we learned in this chapter.